the team can identify interferences between steel framing and mechanical ducts in the building, as well as between site utility networks in the infrastructure design, enabling resolution of any issues between design intent, constructability, and fabrication before construction even begins. Finally, the team can also conduct 4D simulations to understand project phasing and construction sequencing, taking the project one step closer to the field. The Autodesk AEC collection gives every designer, engineer, and contractor the tools and integrated workflows they need to deliver building and infrastructure projects with confidence. Every AEC project begins with an idea and a multidisciplinary team working with a collection of tools to bring that idea to life. Civil engineers start by developing an existing conditions model in InfraWorks. Point cloud data from recap and GIS content, such as sewer and flood information, are added to enrich the model and enable the conceptual design of road and site layouts in the project's real-world context. Switching to building design, a concept is sketched for a health clinic in the site context using Format Pro. The massing is refined, details and materials are added. The impact of sun and shadows is studied, and solar analysis is performed. Insight is used to conduct whole building energy analysis and optimization. Back in InfraWorks, the conceptual models are evaluated within the site context. Next, detailed building design is performed in Revit. The format mass is used to locate architectural elements. Dynamo is used to study alternative roof concepts through computational design. Structural and MEP engineers create models for engineering design, analysis, detailing, and documentation. The design disciplines link their Revit models to ensure the building design remains coordinated throughout the process. As the building design comes together, civil engineers develop the detailed site design in Civil 3D, including parking lot layout, grading, and drainage networks. Using vehicle tracking, even vehicle movement can be simulated and analyzed. Then in InfraWorks, a compelling visual is generated to improve understanding of the design. The next phase of the project is the design of a hospital. As before, the project moves from concept to completion with Format Pro and Revit, starting with architectural elements. Structural and MEP engineering disciplines join the project to create a highly detailed, coordinated building design. During pre-construction, design teams and contractors can perform 3D clash detection on the building and site models in Navisworks. Together, the team can identify interferences between steel framing and mechanical ducts in the building, as well as between site utility networks in the infrastructure design, enabling resolution of any issues between design intent, constructability, and fabrication before construction even begins. Finally, the team can also conduct 4D simulations to understand project phasing and construction sequencing, taking the project one step closer to the field. The Autodesk AEC collection gives every designer, engineer, and contractor the tools and integrated workflows they need to deliver building and infrastructure projects with confidence. Every AEC project begins with an idea and a multidisciplinary team working with a collection of tools to bring that idea to life. Civil engineers start by developing an existing conditions model in InfraWorks. point cloud data from recap and GIS content, such as sewer and flood information, are added to enrich the model and enable the conceptual design of road and site layouts in the project's real-world context. Switching to building design, a concept is sketched for a health clinic in the site context using Format Pro. The massing is refined, details and materials are added. The impact of sun and shadows is studied, and solar analysis is performed. Insight is used to conduct whole building energy analysis and optimization. Back in InfraWorks, the conceptual models are evaluated within the site context. Next, detailed building design is performed in Revit. The format mass is used to locate architectural elements. Dynamo is used to study alternative roof concepts through computational design. Structural and MEP engineers create models for engineering design, analysis, detailing, and documentation. The design disciplines link their Revit models to ensure the building design remains coordinated throughout the process. As the building design comes together, civil engineers develop the detailed site design in Civil 3D, including parking lot layout, grading, and drainage networks. Using vehicle tracking, even vehicle movement can be simulated and analyzed. Then in InfraWorks, a compelling visual is generated to improve understanding of the design. The next phase of the project is the design of a hospital. As before, the project moves from concept to completion with Format Pro and Revit, starting with architectural elements. Structural and MEP engineering disciplines join the project to create a highly detailed, coordinated building design. During pre-construction, design teams and contractors can perform 3D clash detection on the building and site models in Navisworks. Together, the team can identify interferences between steel framing and mechanical ducts in the building, as well as between site utility networks in the infrastructure design, enabling resolution of any issues between design intent, constructability, and fabrication before construction even begins. Finally, the team can also conduct 4D simulations to understand project phasing and construction sequencing, taking the project one step closer to the field. The Autodesk AEC collection gives every designer, engineer, and contractor the tools and integrated workflows they need to deliver building and infrastructure projects with confidence.
First of all, thank you for joining our webinar today. And I will be your host for this webinar. My name is Aljon Bicol, System Sales Consultant of CAM Technologies. And today's session is the third and last episode on data-driven design workflows. So before I proceed with the agenda, first thing first, our house rules. This webinar is recorded and can be accessed in the official YouTube channel of CIM Technologies within 48 hours only. You are muted by default. In case you have concerns, please use the chat box to type in your message. In case you have questions in the middle of the speaker's presentation, please type it in the chat box so that it will be addressed during the open forum or Q&A session. There will be an e-certificate of attendance in case it will be automatically generated to those who will participate and complete the survey later. This webinar is scheduled to last up to 1 hour, including the Q&A. I will introduce to you first our company before introducing the speaker for the main topic. Again, please feel free to type your questions in the chat box as there will be an open forum after the discussion. Then, before we wrap up, we will flash on the screen the quick survey and give you some final announcements. Alright, so before I proceed with the main topic, let me introduce to you our company. CIM Technologies has been providing technology solution from software to hardware for 30 years already. More than that, we are also offering training, technical support, and other expanded services for the AEC and manufacturing industries. These are the solutions we are offering for 3D: conceptual design, detailed design for architectural, MEP, and structural. We also have clash analysis, animations, and photorealistic renderings or visualization, quantity takeoff, construction documents, energy model analysis, and collaboration among project teams. We also have our project management or scheduling for 4D, cost planning and estimates for 5D, building performance analysis for 6D, and facility management for 7D. In case you know someone or you have requirements for manufacturing solutions, here are our offerings. We also have our trusted work large format printers and plotters powered by HP and industry-leading fixed and mobile workstation by Dell. If you want to set an appointment for a virtual demo in HP large format printers, you may send us a message in the chat box. In case you have problems with your maintenance side, we can offer to you our IT services such as maintenance agreement and preventive maintenance for HP plotters and printers, diagnosis and repair, network design layout, network cabling, network configurations, and system or network administration services. We also have our service division, the Altion 3D, to provide you our expanded services such as 2D drafting, large format scanning, printing and plotting, 3D BIM services, prototyping, product design, and many more. Please visit www.alteon3d.com to see other services offering. And we have our training division, which is the Stanford IT Learning, to provide you basic to advanced training and education in the field of AEC, manufacturing, and power and utilities industries. The good news is that our trainings are now available online and you can pay through the website as well. So if you want to learn more about any BIM tools and the best practices or latest trends in related to your job role, you can learn it from Stanford. All right, so I'm humbly presenting to you our partners for the solutions and services that we are offering. Feel free to contact us in case you have requirements that we think we can provide for you. So now, without any further ado, let me turn over the screen to the main speaker, our senior applications engineer, Engineer Kevin Yalu. Engineer Kevin.
Thank you for that, Arjun. Let me share my screen here. Okay. So you see my screen, right? Okay, so before I'll start with my presentation, let me know first, who are you here? So let me raise a poll. Let me know if you are seeing this poll. So we want to know if you have a Revit experience, or maybe a Dynamo experience, or you have tried Project Refinery or Generative Design in Revit. Okay, so I see most of you here have Revit experience, or you're using Revit for your designs. And a couple of you here have tried generative design in Revit, or maybe Project Refinery. Okay. So let me open this some more minutes. Okay, so mostly half of you here have Revit experience. Okay. So I'll end the voting here. Let me share the results. Okay. So I see a lot of you here have Revit experience here, mostly around 50%. And some of you here have tried generative design in Revit. Okay, so let me close that poll. Let me go back here in my presentation. So I welcome you here in our last episode of the AEC Collection Essentials for Generative Design Workflow. So in this session, we will be talking about the workflow that you can do in generative design in Revit. And if you want to share your design study, what will be the workflow in sharing your design studies? Okay, so let's get started. So due to climate change or global warming, we know that our natural resources are diminishing, and that our built environment plays a role in this. So buildings alone consume 25% of our water, and building construction produces 30% of all global waste. So this results in 40% of global energy is used by our built environment. And according to UN, by 2050, nearly 10 billion people will live on the planet. So two-thirds of which will live in cities. So this, they will need houses, bridges, roads, and access to water and power. So there's a great opportunity for AEC professionals to make these things smarter and more responsive to the needs of residents. So this is going to require a lot of design exploration just to uncover the maximum number of options that eventually leads to the optional or optimal choice based on select factors. So these are the factors that could include, for example, less material waste, sustainability, orientation, density, and some other factors as well. But as design projects become more complex, we need to rethink how we are able to make decisions. So research shows that humans and machines working together can make better decisions more quickly. So by using machines to do the heavy analytics, it frees up architects or designers to spend more time discussing the design options with the project team. So this represents a paradigm shift in how we design. Rather than from sketch to completed construction, we are now working from a series of values and parameters to completed construction. So we see generative design as a way to help designers use the computer to adopt more automated ways of performing design exploration. So you might be wondering, what is generative design? So we define it as a form of artificial intelligence dedicated to the creation of better outcomes for products, buildings, infrastructure, and systems. So it utilizes or it uses algorithms, machine learning, and computational geometry to quickly explore multiple solutions to a design problem, and it can yield a wide range of alternatives that are optimized and fully validated. So with generative design, the designer can then choose the best option based on the most critical criteria. So criteria such as density, aesthetics, efficiency, or sustainability. By using the computer to explore many design options and all possible iterations of a design, the more likely the result will hit its mark. Generative design allows AEC professionals to input design priorities and create a series of options that they can pick and choose based on taste or available resources, maybe a client expectations, cost, and other subjective factors. So they can then simultaneously explore and evaluate many design solutions at once. So generative design supports the iteration processes of design and helps speed up the design exploration process. So here are some examples of AEC problems that can greatly benefit from generative design. So from the stadium or theater design up to the facade design. So I'll be focusing more on the neighborhood planning, space planning, and facade design. So for neighborhood planning, optioneering for create designs that can support a variety of criteria. So this can help generative design in those factors. For space planning, you can optimize how you organize available space. So in these times of pandemic, you can also utilize this um, by creating your space plans. So in facade design, you can also create a multitude of design options that can fit your existing criteria. So there are multiple dimensions of optimization that can make this um, difficult problems for human brain um, to generate, and can help machines and machines can help us to solve these problems. So workflow benefits of generative design includes more iteration and design possibilities, elimination of tedious and time-consuming aspects of a project. It can also save you time and reduces costs. So if you are exploring design options it can quickly generate those options for you and can save you time in doing other options as well. It can also reduce in waste. You can make this as a factor for your um, generative design or your design options. And you can also make earlier decision making with the client by showing or by presenting these options to them. So before we proceed with the workflows in generative design, so I want to quickly generate a poll here, wherein I want to know what are your job role. Okay, so are you an architect, a civil engineer, a mechanical engineer, or a BIM modeler? So mostly of you here are architects. So they are this will greatly benefit for architects and also for mechanical engineers and civil engineers as well. Um, Generative design is not only limited with architectural models. You can also use this for civil engineering works, or also for the systems in mechanical engineer designs. Okay. So let me end that poll. These are the results of that poll. Okay. So let me close that poll. Let's go back to the slides. So generative design fits into the vision of the future of work by combining the cognitive thinking of a human with the processing power of a computer. So only a human is going to decide what problem to solve, what goals must be achieved, and what factors are most important to solve a problem. Automation can help organize and prioritize those decisions, but can actually make them. So only people can decide what's important. Okay, so you can filter out what are the important factors in your generative design. Generative design gives architects, engineers, and builders new freedom to design and approach client satisfaction with a renewed focus and responsive and also value-driven design. So this is an opportunity to enhance design skills in design, also for design development and construction documentation, such as visualization and project delivery. So this is while reducing the effort required for pre-design and schematic design. So the designer's role is more critical than ever for implementing generative design. This is because they are the author of the design criteria and defining the problems for the software to explore. So they are also, at the end of the day, the ones making the decisions along with the clients. So generative design allows for design exploration, and software solutions can explore the best design options by factoring in the most important design constraints. So again, this is a design exploration process to quickly generate and evaluate high-performing design alternatives. So until now, many generative design tools have been hard to use because they require our customers or users to know how to code, understand special terminology, or know how genetic algorithms work. Now you can use generative design directly in Revit to quickly generate design alternatives based on your goals, constraints, and inputs. It provides a set of sample study types to demonstrate how this tool can be used to generate outcomes for design challenges. So you can easily run one of the predefined studies or recipes with generative design in Revit, such as workspace layout or massing. So let's suppose you want to determine um, the best arrangement of desk in a large room. So your goals are to maximize the number of desks while also maximizing views to the outside. Okay. And you may also want to minimize the distance from each desk to the nearest exit. So after generative design has completed a study, you can explore the design alternatives to find the solution that meets or that best meets your needs. So these are the results of or the outcomes of your generative design. You can also use this chart to filter and prioritize outcomes by simply clicking and dragging over one or more columns in this section. So another way to review and analyze outcomes is through the scatter plot. You can use this chart options to change the criteria used for the X and Y axis and format the outcome values. So once you've selected the outcome, here, you'd like to implement this in your model by simply select the outcome and then click the Create Revit Elements here, and then the design change will appear in the model immediately. So there are also other recipes that can be used in Revit. One of those is you can maximize window views here. So you may use this sample study type with generative design to generate alternatives to determine the best position in a room for optimal views to the outside. Okay, so by selecting those factors, you can now generate the best or the optimal views to the outside. One of those readily available recipes is the 3-box massing, where you can generate alternatives for 3 adjacent buildings as simple masses. This is to maximize floor area while minimizing your surface area. So in this, you can also view those samples here. They can be rotated and viewed as a 3D object or 3D view. So for the workflows in generative design, in creating a study, so you have to click under the Manage tab in Revit 2021, you have a panel here, which is the generative design. You can click the Create Study here, and a dialog box will appear as in this screen. Okay, so these are the readily available study types. If you are using the Revit 2021 out of the box, you might have only 3 sample study types. But if you have updated to the latest version of Revit 2021, it gives you additional sample study types here. Okay, so once you've clicked the generate or create study here, and you've selected a study type, for example, the workspace layout, you you can select the parameters that you can use in determining or or creating your design options in generative design. So one of those factors is you can maybe select a room where you can quickly generate your the layout of the family instance. For this example, it is a desk in this room. Okay. You can also choose some variables in your generative design study, where you can set the desk row rotation or maybe the spacing between rows. For example, you are generating a layout in your office wherein um, it follows the guidelines for social distancing or um, for these pandemic times. Okay, and you can also set um, your goals here if you want to have an average distance to exits, or views to outside, or a number of desks that you can use in your study type. Okay, so after defining your design goals here or the options in this area, you can now ready to generate those design options. So after generating the design options, these are the outcomes, or you can explore now the outcomes from your um, defined goals. Okay, so these are the sets of um, the outcomes from your design. So if you can actually click one of those, and you can see the parameters or the output goals that you have defined um, the dialog box before. And you can also fill out here from this chart the options that you have generated from before. Okay, so for example, you want to capture the spacing between rows of these desks. Um, you can just select an area here. So for example, from 14 feet to 11 feet here. Okay, and then also for the average distance to exits, you can also filter out those parameters as well. So after selecting those options, and you can now generate those Revit elements into your design. Okay, so uh, that's the first workflow that we have by using the predefined or the out of the box um, design studies. Okay, so another one here is, for example, you don't have, or you have scripts from Dynamo. You can also use that to generate um, your design study. Okay, so if you have input those visual programming here, you can now ready to export that for generative design. Okay, so um, from the generative design tab here from Dynamo, you can click the export for generative design, and then it will give you, or it will validate those logics if it is acceptable. And then you have to fill in those information here, like the description or the image. So the image will be shown here if you have, for example, here in your create study. So the ones that you have uploaded from the Dynamo um, in that dialog box will be shown here. Okay, and another one here is if you want to keep the cache data, or every when you exported this this Dynamo script to your generative design. If you want to clear the cache data, it will be cleared along the way. Okay. So after clicking the export data here, it will be saved in your generative design, in your create study from the manage tab in Revit. And you will now see your generative design here, or your study here. Okay. So in the event that you want to share this study with your colleagues or with um, your partners as well. Okay. So the workflow here is in your computer or in your local computer, you can locate this folder here, the path folder path here, or the file path here. This is the path where it will be saved in your local PC. So there are two files here, or there are that you want to save. First is the Dynamo script here, the .dyn um, file, and then you want to also to share the folder here, the dependencies folder. So the dependencies folder here, it has those needed files for your create study. For example, your the settings, and also for the image that you have uploaded when you are exporting the Dynamo script. So from user one here, you have to share this file or this folder. For example, this workspace layout dependencies, and also for your workspace layout .dyn. Okay, so you can save it in your cloud storage, or maybe in your network shared file folder. And then for user B here, he will extract those files, and then he can now save it from this file path in his or her local PC. So by doing so, it will now generate, okay, or it will now be added from his create study um, dialog box here. Okay, so from there, you can now create a study um, by using the shared study from the other users. So um, there's only the study that can be shared, but not the outcome. Okay, so if you want to generate the same or similar outcomes from the user one here, you must take note of the parameters or the values that um, he encoded from the create study. Okay, so here is the project refinery beta. It is available in Revit 2020. Project Refinery is an Autodesk generative design beta for the AEC industry that can gives user the power to quickly explore and optimize their Dynamo designs. So in Revit 2021, it is now called generative design in Revit. Okay, so by combining Dynamo, a visual programming tool, with an optimization engine, you can quickly explore many design options and pick the best um, outcome that you can have. Okay, so this integrates from your Dynamo for Revit into your Revit environment. So if you want to use um, generative design in Revit 2020, you can use the Project Refinery beta. So if you have an AEC collection or an enterprise license, you can use the generative design in Revit 2021. Okay. So let's say if you are a student or you have a student license, you can also generate, or you can also maybe apply for Revit generative design by following the link below. Okay. It is also available in education license or student license. So if you want to know more in generative design, you can go to this site, to autodesk.com/generative design. And if you have some inquiries regarding our trainings or for price of our software, you can contact the email address here, or you can contact us in our social media platforms. So I'll be sharing, I will be opening the floor now for Q&A. So please type your questions in the chat box. Okay. So I have a question here. So can I access generative design features if I don't subscribe to the AEC collection? So anyone with a Revit 2021 license who wants to build generative design workflows for Revit can do so. But they can use the design option generation, optimization, and exploration capabilities within Dynamo for Revit that is already available in Revit 2021. However, anyone who wants to create and explore their workflows directly in Revit will need to have an AEC collection subscription. Okay. So I have another question here where can I get a trial of generative design in Revit? So a direct access to generative design in Revit from the Manage tab is not available as a trial, but you can experiment with generative design tools in Dynamo for Revit. Okay, so another question here is, how is generative design in Revit different than Dynamo or Project Refinery Beta? So Project Refinery is the name of the beta project that is now being released as generative design in Revit 2021. Okay, generative design in Revit uses the Dynamo graphs just to help you define design logic and produce studies. Okay, so I see a question here. So what's the difference between Revit to AutoCAD? One of the difference in Revit to AutoCAD is the what we call when you model, or if you are doing um, a 2D design in Revit, it will also generate in 3D as well. So the time spent in doing the 3D model or in 2D, for example, I am doing a 2D design in a floor plan. Okay, so it is also generated in other views as well. For example, in your elevations, if you have sections in your design, it will also automatically generate it. Okay, unlike in AutoCAD, you will create a separate file for your or a separate a separate view for your floor plans, for your sections, and also for your elevations. So in that way, um, the time spent in doing those views, it is much longer than doing it in Revit. Okay, and you can also use the Revit model as a reference to other disciplines as well. For example, I am doing an architectural model. I can use this model now for other disciplines. So I can reference this model. For example, I'm doing an MEP project, so I can reference that, and I can also see the elevations of the architectural elements, what are the information in that model, and other elements as well. Okay. Um, Other question here is software for Revit for free, or can we download um, Revit? Okay. Um, it has a free trial. It is a 30-day free trial. After that, you have to purchase Revit for you to continue using the software. Okay. So if you want to know more on this, you can contact the email address that I have flashed before. Okay, so any other questions? Okay, so I have okay, so that's it for me. Aldrin.
Thank you, Sir Engineer Kevin, for your insightful topic. And thank you to our dear participants for your questions. So before we end this session, we would like to know your thoughts about this webinar by answering our poll questions on screen. We will be sending you the e-certificate of attendance once you completed this survey. Right. The first question is, what software are you interested in? Autodesk AEC Collection or Autodesk BIM 360? Second question is, are you interested to enroll for an online training to learn Autodesk software? Third question, how satisfied were you with the webinar? How relevant topic to you? Fifth question, how do you rate the speaker? Okay. And the last question is, would you like to request for a software demo for your company? All right. So thank you for participating on our survey. Your responses are valuable to us, and we will definitely consider your feedback to our future improvements. We will be sending your invitation as well to join our upcoming webinars. All right. So I think we come to the end of this webinar. Once again, thank you, and we look forward to seeing you online to our next webinar session.